build a surface-to-air interceptor for counter-drone operations called Roadrunner. Missile system designed for not just your sort of hobbyist-grade drones, but think nation-state level threats. That was back of the napkin drawing to combat validated in about 2 years.
Welcome to the Emergent Podcast, where we interview product and startup leaders from emerging technology companies about their work in the trenches to bring the hardest and most impactful technologies to life. Today's guest is Matthew Steckman. Matthew is President and Chief Business Officer of Anduril Industries. In his role, he's responsible for leading many of the company's core internal functions, including oversight of corporate operations, executive operations, divisional activities, business performance, and revenue generation. He plays a critical role in shaping Anduril's strategic direction, ensuring operational efficiency and driving sustainable growth across its expanding portfolio of defense and security solutions. Prior to Anduril, Matt served as Chief Revenue Officer for Zipline International, the world's first drone delivery company focusing on medical and blood products. Matt held several leadership positions at Palantir Technologies, running internal business operations and owning relationships with the company's largest customers. Matt holds degrees in computer science and international affairs from Georgetown University. In this episode, Matt Steckman, President and Chief Business Officer of Anduril Industries, reveals how defense technology companies can successfully navigate the complex world of government contracting and product development. We explore Anduril's unique approach of using composable software and hardware components to accelerate development cycles, cutting traditional 5 to 7 year timelines down to 2 years. Matt shares insights on their high-stakes defense deals, including how to deploy 100-person proposal teams, why larger opportunities can be more predictable than smaller ones, and their disciplined build versus buy decision framework. We discuss critical lessons learned scaling from $1 million to over $1 billion in revenue, including the importance of understanding government acquisition at different scales and how Anduril makes strategic decisions about which opportunities to pursue. Drawing from his experiences at both Palantir and Anduril, Matt provides fascinating context on how hardware-software hybrid companies differ from pure software companies, particularly around iteration speed and risk management. We explore their annual strategic planning process where leadership identifies the next big muscle movement needed for growth, evolving from go-to-market capabilities in early years to their current focus on scaling production capacity through their Arsenal One manufacturing facility. Now, a word from our sponsor. This episode is brought to you by Propel Auth. Startups and corporate innovation teams routinely waste months building core user authentication and authorization flows into their products. Propel Auth has automated all the most important pieces of the user management lifecycle. Instantly set up wait lists, magic links, social login, user impersonation, user management, role-based access control, SAML integrations for enterprise, team management, and much more. With Propel Auth, each of these challenges takes just a few lines of code instead of months of development and integration time. And with thoughtful control over design and skinning, it's easy to keep your product fully on brand. Get a generous free starter pack that scales through 1,000 monthly active users, or mention Emergent25 to receive 25% off for the first 6 months for more mature products. Get back to building your actual product and let Propel Auth handle your user management needs. Visit Propel Auth, that's PROPELAUTH.com to learn more. Been pumped to have you on, Matt, so let's go ahead and jump into it. We will start with the basics. Most listeners know that Anduril is a major player in defense technology and autonomy, but not as many people are familiar with the specific products. Can you give us a little bit of a tour through the most impactful ones and the gaps that they're filling in the market?
Absolutely. Well, thanks for having me. I'm excited to do this. Yeah, from the outside, it can be a little opaque on what's happening internally, in particular, like why we can move as fast as we can in some of the domains that we operate in. The history of the company all starts with a core belief that we held and still hold, that software will enable all hardware and robotic systems and allow you to increase, sometimes dramatically, the velocity that you can develop and deploy new hardware, new robotic systems, new weapon systems. And so a lot of what the general observer doesn't see is a massive amount of investment in core software and platform technologies that a customer might never actually see, but they will see the outcome in terms of fulfilling the actual military requirement that they care about. And that's the important part. And so if you think about a stack of technologies, and then you think about Anduril, at the very, very bottom of that pyramid is the core compute. Mainly, that's our internal design and engineering software systems, our production software systems to actually build those types of technologies that also handle some pretty complex supply chain operations. Uh, our software that allows for command and control and integration of sensing and affecting information within the defense world. And then a whole bunch of software around actual physical control systems. So how those robots move throughout the real world. That last piece, I think, is where if you're familiar with um, sort of startup culture in the high tech world, where you're mostly dealing with ones and zeros, that last software stack, I think, is highly differentiated and it's very tangible. And if you walk around an Anduril office, you see a lot of physical stuff sitting on the desks of our hardware engineers, obviously, but also our software engineers, right? Everything ends in a physical manifestation of those ones and zeros. On top of that is some stuff that I think the general observer might know, but just to review, some large aircraft program, the collaborative combat aircraft program with the U.S. Air Force being sort of the biggest one that we're doing now. Underwater systems in the form of large autonomous underwater vehicles. The Australian program is codenamed Ghost Shark. So folks have probably seen that. Air defense systems that protect military servicemen and women and assets around the world. And just an increasing number of larger, more complex sensing, affecting, and understanding systems around the world.
Wow, that's quite a breadth of products. We'll get to a question coming up around how you guys select those. I guess one of the things that this makes me wonder, though, is a lot of companies aspire to build many products over time, and they don't even get traction on the first one. What are some of the keys that have made it possible for Anduril to not only exceed with its first products, but also with what, to outside observers, appears to be sort of one hit after another for major defense systems?
So the first thing is defense is weird as an industry. And I think that framing is important for anybody in really any commercial industry, tech. Um, Maybe you get a little of this in like the large industrial sort of part of the economic ecosystem. Um, but in defense, you have a very punctuated set of successes. There's not like little wins that then add up to a large book of business over time, like you would see in a SaaS style sort of traditional technology business. Salesforce, good example, probably the example. It is a handful of very large wins that are highly durable, meaning they basically mostly don't go away if you don't mess it up. And each year, just to give you some perspective, uh, there's only a handful of opportunities that we need to win every year in order to make the business go. I'll be more specific. We will probably this year close on the order of 300 to 400 separate contracts to deliver something, whether that's a piece of robotic machinery, software, whatever it is. Only 20 of those are probably material to the actual revenue of the business. And so the question is, okay, what are the other 380 deals for? Well, not just a waste of time. In defense, you have to very rigorously build up your capacity to do more and more complex things, more and more sensitive things that have to do with the survivability of people, things that have to do with the lethality of the fighting force. You can't just jump right into those things. You have to basically earn your way and earn your right to sit at that table to have that discussion. And that's what those other 380 things are doing. And so part of I think the specialness of Anduril is we are humble enough to know that there's certain tables we shouldn't actually sit around. And we actually freely admit to the government when that's the case. Like, we are not ready for XYZ. But we're interested in it and we want to earn it. And we've become very good at figuring out the series of things that you need to lay out to earn that position to then compete on that large program. And then competing on the large program, it's talent, it's technology. I think for us, it's mostly, does the government have urgency? I.e., will they help us and partner with us to break down some of the traditional bureaucratic barriers to working with defense? You find that in urgent programs. Do we have a technical tailwind? So has the stuff we have created prior actually helped us? Or is this completely de novo, in which case we probably have a whole lot of headwinds working against us? And then uniquely in defense, I think, is do we understand deeply how the government's going to pay for those things, whether it's a one-time thing or over time? And that's a whole other set of skills that are somewhat mysterious if you don't work within the defense world. But all three of those things kind of have to exist in order for us to give a go at doing something, fairly major.
And so for that philosophy to work, for you guys to respond to an urgent need, but without having built that product per se already, is the way that you're sort of prepared to execute when that happens, all of those smaller contracts? Like, you've already been in the room and maybe you weren't building the exact thing, and then you sort of add that piece plus the software lattice platform to bring it together. Like, how do you like quickly surge on something that is incredibly difficult but hasn't really been done, right?
It's a combination of things. Always these things are, it's like there's never one single answer, right? I think people that kind of distill the world down into single answers, it's like, yeah, have you actually worked in this world before? In defense, it's usually like 12-dimensional chess wrapped in a burrito. So how do you do it? So the first thing is you build your technology portfolio such that the software and hardware components are composable. So across our current technology portfolio, and there's a bunch of different ways you can calculate it, but there's probably roughly on the order of 100 to 150 software services. And then there are probably that same order of magnitude composable hardware components. Where think about this as the most fun and complex Lego project that any child could face themselves with. So if we don't have the answer, and we don't, I don't think we've ever competed on a program where we have the perfect answer. But maybe we have 30% of it. Maybe we have 50% of it. Maybe we have 80% of it, and it's really just some minor modifications and off we go. I think that is the technical tailwind that we talk about that allows us to attack problems and almost, in many cases, double the speed to fielding of a traditional program. I'll give you an example. We build a surface-to-air interceptor for counter-drone operations called Roadrunner. So this is a very fast, very accurate missile system designed for not just your sort of hobbyist grade drones, but think nation state level threats. That was back of the napkin drawing to combat validated in about 2 years. A traditional system is about 5 to 7. And so at that clip, right, it's not magic, right? Like nothing magical is happening to do it. It's because we had a lot of the core sensing systems. We had a lot of the core navigation systems. We had a lot of the core targeting systems. And so we didn't have to start over again. We could apply all of that smartly to this new problem and accelerate our ability to get something to the field.
I love that. Composable hardware and software combined. You guys must be there must be a lot of really interesting whiteboard sessions to figure out what are the correct hardware software abstractions to even tackle something like that.
Yeah, and then like, do I actually hate the thing that we have internally, and do I have to make an argument to design a new one? That's always a fun one as well.
Yeah, yeah. My goodness. So, one of the questions that I get all the time, and I'm sure you get all the time from earlier stage startups that want to do something either in government or in defense is how do you become a program of record? And, there's a lot of things you can look up, sort of the academic steps to do this, win this SBIR, then go to this phase, then compete for that phase. And I'm curious for someone like you who has had so much success in so many different companies cracking this particular nut at massive scale, like how's it really done in practice? How do you actually go from stage one to stage two to stage three? Or do you even follow the stages? Like, how do you think about it?
When you do it enough, you kind of know when it's working and you don't, but let's try and like actually break it down. Um, so the first piece of advice that I give, like any new company trying to work with government is just ask the questions to the government that you want to ask, and don't feel silly or bashful in asking something, because government understands that as a new company or new to the industry, they don't have an expectation that you know how some of these strange technocratic pieces work. And particularly when you're a small company, um, the vast majority of government officials will want to work with you and see you be successful. I think once you hit a certain amount of scale, there's a competitive dynamic, and you won't probably get as much specific information from your customers. But when you're early, just literally ask the questions, and as many details as you can pull from as many people in that environment. Um, how are these things contracted? What's the timeline for budgeting? Is there a competition process? Who are the key leaders that actually care about this? What are the operational requirements? How hard are those requirements? How are you thinking about testing and evaluation? All of these things are fair game. I think the number one issue I see most, and even in like my new folks on my team, is they're just bashful and don't want to ask the question that they think they should know the answer to already. In my experience, this stuff is sometimes so confusing that um, your government will freely admit that's a good question. And I'm glad you asked. Let's actually figure out how to do this together. Um, beyond that, the other piece here is I think a lot of new entrants underestimate the sheer scale of government acquisition. So, what I mean by that is to move the needle in a government program, you're talking about 9 or 10 figures a year, mostly when you think about these large programs of record. And um, you're also talking about how that program interacts with the millions of people that are actually working within the defense community. And the apparatus that surrounds that piece of technology also has to work. And it's a massive systems design problem, right? It's not just the thing you're providing, but it's everything else that surrounds that piece of kit that will make it actually work within the most complex organization that's probably on the planet, right? And so you see an underestimation of that complexity. Um, and so you're not going in having fully thought through the systems problem, and therefore the government can't really conceptualize how they would partner and work with you. You're not really conceptualizing the amount of capital and people you need to bring to bear against the problem. You're not really conceptualizing, if it works, the speed at which you have to ramp to scale. And if you don't do any of those things, the government is going to say, I don't believe you. There's no believability to what you're proposing. And you're going to be miffed and sad when you hear that, but they're probably right. Um, and so if you don't underestimate it, you think through all of these things, you have a chance. And then you're shooting at a sizable target where you can actually make your business work. Anything smaller than what I'm describing, it's actually hard to make. Let's stick to venture scale companies. It's actually hard to make a venture scale company work if you're not shooting at those lofty goals and winning.
Wow, fascinating. Yeah, I think it's common for people to forget that the Federal Acquisition Register, the rules for how government procurement is supposed to be done are simultaneously being interpreted by the companies bidding on them and interpreted by the government organizations that are actually creating those contracts, which is, I think, why you see this high variance in the way solicitations are structured, the process around it. So you're basically saying, look, a lot of companies go in and they're just thinking about their SKU, and they're not thinking about how that SKU integrates into the broader environment, the people, the ecosystem, the other technologies. And so it takes this wide lens. Is that about accurate?
You got it. And if you go in and you don't at least appreciate where your SKU, which is probably the right way to put it, fits within the ecosystem, you're going to have problems. There's a trust factor to doing particularly things that involve survivability and lethality, where if the government doesn't trust that you really understand their problem, even if you're not solving all of it, which is fine, it's going to be hard for them to get over um, letting you in the door. And so it's incumbent upon um, my company, all these companies trying to operate, to do your homework and to walk into that room, at least telling the customer that you've tried really damn hard to understand everything, and you might not know everything because you don't have access to all of the information, but um, you're curious about the system and the systems level problems that surround the thing that you're trying to do.
Okay, so standing back, thinking about all these pieces coming together, what is Anduril's sales strategy? And in a company that's going after deal sizes that are so massive, where the government's obviously going to have a lot of leverage in terms of, can you do this piece? Can you do this piece? How do you square that up with product? What are your mental models for making sure that neither sales surprises product nor the reverse, and that you guys can act in concert?
It's interesting. The counterintuitive sort of piece here that we've discovered is the bigger the opportunity, the easier it is. It's kind of weird. So, a good word for this is forecastability. So, in a large opportunity, um, I personally have a huge ability to forecast uh, need, expenditure, time horizons, capex, opex, how you have to scale a team, uh, down to the specific types of heads needed over time, um, because you have a ton of forewarning, right, in terms of what's going to occur. I find that the hardest part about the defense business is the unforecasted, urgent, small things that you didn't know about that you then have to react to. Because in defense, there's limited elasticity in terms of what you can do, particularly in hardware systems, where, I mean, we have some relatively simple systems, I think, that you and I would consider where, a single part of that system is a 6-month lead time in order to get it shipped to us. Um, and so the balance becomes, how do you create capacity and elasticity to a degree without destroying your company in the process? And the way you destroy your company is you way overextend and you way overbuy and you burn a lot of capital, and then your revenue sort of dramatically lags behind. And so what we've noticed is this like weird dynamic where, our 20 or so largest, deals um, are kind of known and forecastable, and we know what we're doing, and we know what time to execute and to pull all the levers. Um, it's those 380 that are actually the hard part about the business, because you want to be able to move fast, but you don't want to light all your capital on fire in order to do it.
Yeah, but are you guys sitting there and saying, "Hey, we're gonna build autonomous submarines, and now we're gonna go bid on autonomous submarine work?" Or do you say, "We bid on giant autonomous submarine work, now we're gonna build autonomous submarines," you know?
Yeah, it's kind of a blend. So it's more like, based on all of the things that we know about government, and I think we've done I hope empirically a world-class job at bringing in people into the company that deeply understand sort of these macro movements in government and technology. I think that's one thing that over my tenure at Anduril, I'm particularly proud of, the ability to really deeply understand where things are going. And you're not always perfect, but um, uh, the example here of submarines is great, right? So years and years ago, through a bunch of different, call them human sensors, for lack of a better term, it's very clear that there's going to be a large movement into undersea sensing, undersea warfare, undersea capabilities. And that is sort of 6 months prior to when we did the acquisition of Dive Technologies, located just south of Boston. Because of a lot of things, that results very quickly in having a product we can build off of that is, it's a platform, right? It's very composable in and of itself in terms of what you can do with it, software you can put on it, the hardware payloads that you can put in it. That very quickly translated into significant amounts of government work, mainly the Go Shark program with the Australian Navy, which is very large, entering its production phase, has been very successful for us. And so I don't think it's never we have this idea, we're just going to YOLO it and spend a whole bunch of money and build. It's always deeply informed by everything that we are seeing and understanding about government need and where they're going with their technology portfolios.
Yeah, it takes a lot of conviction to believe in that, but I love that. That's cool. The Let's talk about massive investments. So one of your most recently announced massive investments is the Arsenal One manufacturing facility in Ohio, which I think, if I'm correct, will be one of the largest defense manufacturing facilities in the world. Obviously, this is a major step in scaling your production capabilities. What drove the decision to start building this facility? How does it fit into the broader strategy for meeting the growing demands of the company? And then, if I can see this as well, my understanding is that your software is also involved in some degree to connect the autonomous pieces of the factory. Sounds too good to be true. Like, help us understand this story. It sounds really interesting.
Yeah. It really all goes back to elasticity and forecastability. So, um, because we're a new company, we have the ability to make first principle choices, to steal your term. And in the broader defense world, you have a lot of distributed manufacturing capability. There's a lot of reasons for it, mostly historic. Um, but if you had the ability to make a choice from the beginning, you very quickly start to all kind of converge on it. Probably should all be in one place because you get massive gains of elasticity out of having everything together. And so, a very simple example: we build multiple types of small UAVs, Bolt, Ghost, Altius, so on and so forth. Um, there's a lot of shared resources and a lot of shared technicians that go into the construction, both hardware, software, and then the people involved in building those things. When you look at how our contracts come in, they are really spiky in nature. Um, they blend together over time to look smooth, but they are not smooth. And so you can have a production line that's firing on all cylinders for 6 months and then completely wiped because the next order isn't for 2 years. The ability to then be able to move uh, the human capital and frankly some of the actual technology itself in the process of manufacturing to whatever that next demand is means that you can deal with spikes in forecasting and ultimately, uh, importantly, not have to bill that through to your customer, right? Because if you were to keep a line open for one product line singularly, maybe the customer sees this, maybe they don't, but you have to have enough operating capital in order to keep that thing kind of warm, would be the term. So that way, when the spike happens, you're not starting from scratch. And so the customer usually will see that in just an increased price per SKU. what we're trying to avoid is having effectively that tax live on all of our products, because we can be a lot more dynamic in how we shift resources across one mega factory in Arsenal One. There's a lot of other sort of benefits to centralization, skills and training, common work-base, common tooling. You mentioned software systems that allow us to quickly design and spin up and spin down lines, software systems that help us not even design something that can't be produced in our facility, which is an interesting concept in and of itself. So I, as a mechanical or electrical engineer, I shouldn't be allowed to make a choice, or it should be very hard for me to make a choice where the end product that I end up with is not able to be produced in Arsenal One. And I should have software that's protecting me through those choices. And yes, we'll make exceptions, like exceptions will only exist. But for the most part, everything we want to build as a company and all the software systems we use to do that have to be aware of the capacity and tooling and construction of Arsenal One, so that we're not stuck at the end of the day having something that is very exquisite, is artisanal, and can't be pumped through these lines using some of those elastic benefits.
Fascinating. Okay. Yeah. I think I see what you're saying. It's sort of like if someone's working on the guidance systems for Altius and the Altius orders drop off, maybe that same group of people, that same hardware, the same software for managing it can be shifted over to one of the other UAVs, for example.
Yeah.
Yeah.
Conceptually, that's right. That's spot on.
This episode is brought to you by FlyKit, FLYKITT, the first full solution to jet lag. This might seem hard to believe, but I've flown from Los Angeles to Tokyo and back with virtually no jet lag using FlyKit. Based on research with Navy SEALs and fighter pilots, the FlyKit team discovered that long flights cause inflammation in addition to disrupting your circadian rhythm. And they figured out how to solve both these challenges using a customized program for when to eat, sleep, and use their patented supplements and blue light blocking glasses. It's simple to follow, and you don't have to change anything before your travel day. With FlyKit, more than 90% of people can sleep well in Europe, Asia, or anywhere else in the world on night one. Visit flykit.com and use coupon code FLYWITHEMERGENT to get 15% off FlyKit.
Okay, let's look at how we win one of these massive deals. What is the anatomy of a massive successful deal team for you guys? Who's on it? What does it do differently from the legacy players? Do you have dedicated engineering resources on these teams? Like, what does that look like?
For the big programs, they're very big. I mean, sometimes hundreds of people, which is, again, to outsiders in defense, a bids and proposals team of hundreds of people all doing work is pretty crazy. And it looks exactly like kind of a mini version of what the ultimate program team would look like, with a capture manager, a strategy manager, a chief engineer, all of the engineering disciplines you would need in the construct of that program. But then even outside of that, we focus a lot on the executive level interaction. So what can we do in the broader government to understand the customer, understand where we're positioned, where the government thinks we're strong, where the government thinks we're weak. A government relations function that is sort of wrapped around all of that to understand the congressional dynamics, the Pentagon budget office dynamics, how that wraps into the program. And then I don't think uniquely, but we focus a lot on how is the team aligned? How does everyone understand what their role is on it, what the goals are for every week, month, quarter. Sometimes these competitions can be a year long, if not more than that. And all of the transparency functions that kind of control how those communications work.
And are people assigned to these teams like full time during that time, or are they, part time and after? Wow. Okay.
They are for the really big ones. Full time. For smaller ones, it's an other duty as assigned in many cases. But yeah, for the really big ones, it's full on.
Yeah. Okay. So, I mean, you're not small. You're also not 100,000 employees. So there must be some things that you have to decide that you're not going to go after. how do you guys decide what are some of the things that Anduril is not going after in defense? Because again, from the outside, it feels like any day there could be an announcement of literally fill in the blank hard defense hardware. It's going to happen.
Well, it's really what's kind of interesting is, yes, it looks like we're going after a lot of different things, but I think one of the key things that a lot of people underestimate is the expense of the common elements you would need to bring into any robotics program, no matter what, in terms of design and control and movement, and things like that. Safety, test, validation. All of those are, for the most part, common. And so only because I have the benefit of having been at Anduril, almost since the beginning, the product branches are actually, they're always an adjacency. And so to go way back, our first product was the Sentry Tower that is now deployed over half the U.S. southern border, lots of military bases around the world, doing autonomous understanding of the environment and where the threats are and things like that. The natural adjacency to that was, well, let's point all these cameras into the air, right? And now we're starting to get into counter unmanned systems, COAS, which is a big and hot topic in the Defense Department right now. You can look at all the New Jersey reporting for some fun news hits on that. But that's a product adjacency. So what it means is when we started competing on those programs, we already knew a whole bunch about the problem, particularly at the subsystem level, the sensor control level, and the communication network level. And then some of the sensor fusion algorithms that actually derive what those objects are. And so what is the commonality between a CCA unmanned fighter jet and a Sentry Tower on the southern border? It's actually a lot more than you would expect. And I think, because a lot of us have big platform and software backgrounds, we understand the amount of investment in that core technology that it takes. And I think that ends up being part of the special part of the company and the approach, is that we actually can, in technology and in code, tie these very, very different systems together so that a lot is common.
Yeah, got it. What are some bets that you guys have tried and then killed? And, where you took that common core and tried to adapt something, what assumptions proved untrue? How'd you guys figure it out?
I would say for the most part, where we've had a technical bet that hasn't manifested, there just wasn't government appetite for it. So normally it would fill an actual problem. Like, we weren't building it because we didn't think there was a problem, but the problem wasn't big enough that you could get the government over all of the other complexities to fielding any new piece of technology. Like I mentioned, that systems level problem. There's a lot of inertia you need to break for anything that new to be deployed. I mean, just think about deploying something simple like a new radio to the Army. Think about the number of people you have to train in order to use it. And so there's not the switching costs at the scales we're talking about are quite large in even the simplest of technology cases. And so a lot of times we underestimated those, and we built it. It was interesting. Government said, "Oh, that's cool," but was it really worth all of the inertia that would have to be broken in order to deploy it? Like, no. I think the important part is we didn't get too far in, and we didn't burn that much capital that it posed a risk to the company. But they certainly exist, and we learn from them. I would say, very oddly, we are like very accurate at our bets that we make. We're not wrong a lot because we take a lot of pride in the understanding of the customer side prior to making any of these investments. But when we're wrong, we try and exit quickly.
Are you willing to share some of those examples or maybe one of them?
They're not like, I don't think they're useful. I mean,
Okay.
random communication systems, sensor devices, small sensor devices, some smaller aerial systems. Um, if you look at our portfolio, there's probably been a failure in most versions of the technology that we build, and just hasn't fit the market.
Yeah, yeah. That's a really interesting point though about just for at the scale that you guys are going after, like maybe other companies could be successful in smaller scale, but they're not going to become $100 billion companies, right? They're going to become something much smaller than that if they go after some of those smaller problems. And in those smaller problems, they might not get over the inertia to be able to build them. So yeah, it's interesting. I feel like you're describing a landscape that has some serious market failures for the warfighter in the sense that there are certain things that they really need, but they're not actually willing to procure them, and therefore the market's not willing to build them.
Yeah, it's like a dominant design problem, right? So it's like, when is the switching cost worth it? And at the scales of the Department of Defense or national security community, um, it's got to be a lot better than the current in order to justify, a massive set of actions to replace a current incumbent product. It just does. Um, and I don't necessarily think that's wrong, given all of the other trade offs that would be involved.
From the outside, it seems like Anduril basically takes known defense hardware challenges, makes them autonomous, links them all together, and then improves pretty much each specification for the item by 10 or 100x. More durable drones with longer battery life, higher durability. Is this analysis too simplistic? Like, what else goes into making a product the Anduril way?
I think part of the thesis is breaking up what would otherwise be a system that was all packaged together into one very expensive, single exquisite asset, breaking up everything that it does into its component parts and figuring out if you can do it in a distributed way. And so, can I take the mission, um, that an aircraft would perform, and maybe that aircraft is actually performing 12 missions? And can I have 12 separate things that together are much less expensive, much less exquisite, easier to produce? But can I link them all together with highly complex software in order to achieve more than that single exquisite system would have achieved? Like, that is actually the thesis that underpins a lot of the technical approach, is the breaking apart of these problems and then figuring out, only with the advantage of advanced command and control software, advanced mission autonomy software, where if we didn't have it, that approach would be impossible in the first place. Can we break it apart? Can create composable systems, software and hardware? And can that entire network of things outperform the current way that we do it?
Fascinating. Yeah. So we should expect to see over time for bets that Anduril makes sort of more variance within each bet in order to satisfy the broader set of use cases. Did I
I
understand that
think
correctly?
so. Yeah, more
Yeah.
heterogeneity. Yeah,
Hmm.
that's probably right.
Yeah. Interesting. How do you guys make build versus buy decisions? For example, I know you guys recently worked with Apex for a satellite bus, Saronic for submarines. How do you decide versus building these yourselves? Obviously, you guys have an incredible bench of technical talent. So, like for some companies, they're deciding could we build it. I don't think that's really an issue for Anduril. So, how do you guys decide?
Yeah, I would say, first off, we mostly buy things, and we mostly do the complex integration and the software integration needed to bring all of those things together. So the vast majority of our technology are sort of best in class analysis across the supply chain. The build stuff comes into play, really only when there's a market gap. So we have found nothing that meets the cost, schedule, or performance that we need. And we believe, and you have to really believe it, because mostly you're lying to yourself when it comes to build versus buy, that we can beat one of those three things. Can we do it cheaper? Can we do it faster, more producible? Or can we eke out a performance gain in some way? We will only take on a project if we have deep conviction that we can beat one of those core three pillars of how we and the government evaluates technology programs. Um, and a lot of this is resident on our core software and hardware teams. We have a mission systems division where they literally invent new technology from like pure R&D all the way through fielding. And then throughout the rest of our divisions, it's a kind of a peanut butter spread of activity. But I think we are probably unusually risk averse to build when a buy will solve the problem and we can do the software and the integration pieces.
That's very mature of you guys. I feel like most companies, like you said, they fall deeply into the trap of assuming they're the only ones who
Yeah,
can
it's
build
probably
it
because
better.
we've made all of those mistakes and learned it the hard way.
This episode is brought to you by Chaser. Chaser is a task management solution completely embedded in Slack. When teammates have requests for each other, it's no longer necessary to involve a project manager, add the issues to a task tracker, and remember to follow up. Right from within any Slack channel or message, with a few simple keystrokes, you can identify a message as a task for another person or yourself, and Chaser automatically tracks it and reminds the assignee of the work until it's done. We started using Chaser at First Principles to create stronger clarity on those important but less formal tasks that must happen to get from start to finish on a project, but that often don't arise until the middle of a discussion. We now spend less time context switching, and we're not dropping the ball on each other. Plus, there's great transparency into who does what in order to bring the team to success. Get a 14-day free trial at www.trychaser.com and use the code FP50 to get 50% off your first 3 months. Let's jump back into the sales realm for a minute. A lot of startups selling to government, they're not sure how to balance participating in the solicitation processes, these heavy machines that we've already talked about, versus doing sort of true outbound sales. How do you decide what extent your organization is going to do outbound sales, versus simply participating in these RFXs?
It's both. So the way to think about it is sort of the outbound engagements is how you're informing the government of what's in the realm of possible, and ultimately how you're shaping their thinking on how they should go about acquiring and fielding a certain type of technology. Um, that in most cases will lead to some form of competition. Every once in a while, the government will do something called the sole source award, where they believe you're the only source for that piece of gear. That's unusual. Mostly it will lead to a competition. Your goal, though, is once it hits that phase, that you have shared everything with the government that you possibly could have, so that when you compete, for the most part, you're the thing they're asking for, or you're one of the three things they're asking for, and then you're going to go and field and actually test the metal of all of the products where you think you have an advantage. And that's, for us, a big part of the philosophy. So the one thing that we try and convince all of our customers on is, in some phase of the competition, demand fielding or demand some demonstration of the real software and hardware stack. We always feel like we have a tailwind when the competition demands actually showing something. And a lot of that is because, again, we're coming in with a lot of the building blocks we already need. And so we feel like it's an advantage to us if we're being tested. In some cases, that introduces risk, but I think, for the most part, if not 100% of the time, for us, that risk is worth the ultimate outcome in the competition.
And you don't end up off-roading too much, because part of your job is to deeply understand where is R&D at, where is composability at, so you can make sure that the team is going after stuff that fit. Like, it may stretch the company, but it's not going to stretch it too much because you have high awareness of where the technology is.
Yeah, and to the point where if we're going after something that is a really big stretch, like our literal gate will flag, like just to get into like process stuff, like in our CRM, a thing will flag and it'll say, we're asking for a whole bunch of internal money to go after this thing, which probably implies we don't have most of the building blocks needed to go after the thing. And that will trigger a set of reviews where at increasing levels, if it's a small amount of money, maybe it's at one level. If it's a lot of capital, it might get all the way up to the executive committee, where we as the executive committee accept the risk if we're spending a whole lot of capital going after a stretch goal. That doesn't happen a lot, maybe 2 or 3 times a year. But I would say when they do happen, in many cases, they're some of the defining programs that the company holds. But I think it's very important that all of the teams can take as much risk as you're willing to afford them. And I think that our risk appetite as a company is pretty high, uncomfortably high for a lot of people. But there are some risks that actually have to be debated, and we debate them.
Yeah, I would argue you guys take a lot of risk, but you take it within your strategy. And I think that's sort of the safest kind of risk. It doesn't mean it's going to work, but it means that there's a strong narrative for making it work. There's a strong chance of bringing the pieces together to make it work. After Palantir, I believe this is your second hardware software hybrid company, Zipline and Anduril. And I think this is a fascinating area. My personal belief is that the hardware software hybrids of the world are going to be some of the most important world changing companies over the next 10 to 15 years. What have you seen that's different in these settings, besides the sort of obvious fact that it takes longer to build hardware? Like, what new lessons have you learned from being right in between those two universes?
I think that the biggest difference is on the technology stack. It's the iteration speed. I was at Palantir from 2009 to 2017, and I was in a ton of conversations where, on the fly, or almost on the fly, in situ for sure, you could kind of debate with a customer new things that you could do. And those new things could be done to a degree relatively rapidly, depending on what you were talking about. And I think there was a highly iterative, highly creative part of the Palantir culture that drives the company for sure today. And I think is part of the reason why you've seen an explosion of companies founded by Palantir alum is you could literally in the trenches be designing new products. It was an amazing set of experiences. You cannot do that in the hardware world. You can speculate. It's very difficult to commit in a room. A lot more goes back to true design studies, true modeling and simulation, true sort of physical understanding of, okay, you presented me with a new problem, what can I do? But then the length of time to then get at that problem is, for people coming from the software world, really, really long. I mean, many, many years, right? Until you can actually go and deliver something. That key difference dramatically changes how you structure a company, and in my role, dramatically changes how you go to market. It's more exacting. There's a lot more dialogue between the core engineering teams, core platform teams, the go-to-market teams, because you can't commit the company to something that's going to commit us to a 3-year journey. You can't do those things lightly. I think in the software world, you can commit quickly because things can be done quickly. It's not the same when you're blending the two together.
And what's the longest pole in the tent? Is it waiting for rare parts? Is it when you put these 5 Legos together, they just don't work the way that you expect? What ends up being the surprising thing coming from software to hardware?
It is almost purely testing and evaluation. So once I have the first article, or second or third, the length, amount, and expense of putting it through its paces so that every edge case is tested. You understand deterministically exactly how it's going to perform in every setting, or you have a whole bunch of exit scenarios if something goes wrong. The entire testing and evaluation apparatus that surrounds these things is probably 2 orders of magnitude larger than if you're coming from the pure software world. A simple drone to get an airworthiness certification is probably 12 to 18 months of testing.
And how long is it just to make it fly the first time in prototype grade? Like a couple
Maybe,
weeks?
3-4 months. Exactly.
A couple of months. Okay. Wow.
Yeah.
Wow. So that entire rest of that time, that's really interesting. So it's sort of like you have to do more homework up front. So you've almost got to be a little more disciplined about your bets. And then once your bets come out, to make them work in a way where you're not going to field them and then have 100 problems that undermine the program. There's just this very intensive sort of certification and testing and evaluation process to make sure it really does what it's supposed to do.
You got it.
Okay. Okay. Going back in history now, thinking about the earlier days, what were some of the hardest lessons going from $1 million in revenue to 100 million, and then from 100 to now over $1 billion?
I would say that the sort of dramatic leaps in government, like you can basically do $10 million deals or less, and have kind of no idea what you're doing in terms of how the government works. You really can. Like, you have a good product, it fills a niche. The government's able to execute on 10 million or less in a lot of different unique sort of transactional authorities that give the government flexibility. And you can do a lot of those and you can get to 100 million in revenue without having like a really crazy business development, government relations apparatus that surrounds you. There's like a natural breaking point with government where you literally can't do the same set of activities to go from 10 to 100 or 100 to $1 billion. It's like actually a new set of laws in many cases that you have to deal with. And so I think what we've been pretty good at is, January 1st every year is trying to figure out the big muscle movements we want to make as a company. And so in the early days, every year, January 1st, myself and the rest of the leaders of the company, Brian Schimpf, Palmer, Trey, Chris Brose, we would literally say, like, what do we need to change? And then for Chris and I, it was normally, what are those big muscle movements in the go-to-market apparatus that we don't have that we need to have? And I think the last 7-8 years of the company was every year there was something we needed to change in order to go after larger and larger programs. And then today, like, we basically have everything you need in order to really approach any kind of program. We're probably not making, nuclear submarines anytime soon, but that's a little bit unique. But pretty much we can get into any room and feel comfortable. We have the infrastructure needed to go after things. This year, it's not about the bigger muscle movement we need to change in terms of go-to-market. It's all about Arsenal One, and it's all about production capacity. So we know that now the greatest rate limiter to the company is literally how many robots we can produce and get to the field as fast as we possibly can across a huge array of domains. And so everybody at the company, me, Chris, everyone, all of our go-to-market people, we're all focused on the production problem, how to think about this with government, how to think about it creatively, how to, on our side, ink contracts that already consider production and production challenges from the very beginning. And there's a lot of like weird things and minutia you need to kind of build into these things to be successful. But that's the big muscle movement for us this year. Every year we kind of tell the broader company, we're growing so fast that it literally is a different company every single year. That is very true. We hired 1,900 people last year. We are a different company this year. And so you have to change big things. And the willingness to do a little bit of creative destruction, I think, is a defining characteristic.
Yeah, kudos to you guys for holding the discipline, but also being willing to make hard decisions each year and then holding to that. Final question for you, nice and easy. Where can people find you and stay in touch about what's coming next for Anduril?
Yeah. Well, I think we're on all of the social medias. We have a really amazing communications and design department that keeps everybody informed. I even learn sometimes about stuff. More importantly, if you're interested in working at the company, we're still in a sprint for the best talent in the world. All of our job openings are public on our website, anduril.com, and apply. I think if you've ever wanted to get into defense and national security for so many reasons, I think the geopolitical environment being the principal among them, now is the time to try it if you've always wanted to try it. I think Anduril is a great company to come and do it at. We're fast. We deal with urgent things. We try and put our best people against actual important problems. We try and limit the number of bureaucratic processes and issues with customers that we run into so that our engineers can just go to work. And so we'd love to have you if you're interested, and check us out.
Fantastic. Thanks so much for coming on, Matt. I really appreciate it.
Thank you. Appreciate it.
Thank you so much for listening. Emergent is brought to you by First Principles, where we provide emerging technology product coaching and fractional product leadership to founders with bold visions. If you found this valuable, you can subscribe on Spotify, Apple, or wherever you get your podcasts. Please consider leaving a review or sharing feedback directly with us. You can always find previous episodes, show notes, and more content on www.emergentproduct.com.